My name is Matt Alexander. I'm the current acting associate dean and director for computer science. And joining me today is Holly Foster-Bolson, who is our senior manager over our program mentoring faculty for computer science. So thank you all for joining us. We'll get started here by hopefully watching a video over what is computer science here. And I'm going to try to share the audio.
It's all about the 4K i9 32 gig super.
Yes, good.
Computer scientists probably make. Well, yes, but really, no. Let me break it down. So we have a laptop, the usual stuff. The hard drive, the screen, the processor, the design. And the person who deals with this all is the computer engineer. They're the ones who create the device. Okay, so what about the software then? You know, Microsoft Office, Photoshop, Google Chrome, and the operating system, of course. Meet the computer programmers and the software engineers. Hold on. Isn't this video on computer science? So where do they fit into this? Time to dig a little deeper. Say you're on the computer surfing the web and wanted to find out what song was currently #1. You have 4 websites to choose from. How would you decide which one to choose? Obviously, it's the most popular one, right? But what if they were all as popular as each other? What if they all had very similar content? How would you know which one is best? Well, a couple of guys spent some time working on this and managed to create an algorithm to figure that out for you. It's called Google. Yes, Google. And this is what computer scientists do. They're the ones making the magic happen, really making our lives easier. But the engineers, the programmers, the scientists, they all work together to deliver those beautiful phones and computers packed with incredible software so we can do what we do. So back to algorithms. Think about when you're traveling to work in the morning. How do you know what the best route is? You would need to figure out where everyone is and where they're going. Then and only then do you know what the best route is. And guess who writes the algorithms to work that out? And these algorithms are everywhere. From connecting computers together through AI and improving the way we communicate with robots. If you can't think of the last time you did this, think about Siri, Hey Google, and Alexa. Meet the Internet of Things, aka IoT. Like when you say, Hey Alexa, turn the lights off at home. And if that wasn't enough, what about those smartwatches that can detect if you've fallen over? Yes, algorithms strike again. And you know those computer engineers, software engineers, and programmers? They all play a massive part in this too. It's like one big family. Imagine you had a drugs trial involving thousands of cancer patients. You've nailed the algorithms to make sense of it all. But what about storing this data? It's very sensitive and needs to be safe from criminals. And this is where maths is involved. But not the maths you're thinking about. You know, where you have to figure out what X is. Welcome to the world of prime numbers, the fundamentals in encrypting data. You see, it's pretty easy to take 2 very large prime numbers and multiply them together. But just imagine if you had to do the opposite. Say you were given a very, very large number, and you have to find out the only 2 prime numbers that make up this number. Seriously, where would you even start? Now, we can't do this very fast, but computers can. But even then, they are limited by their power to how fast they can compute. And this is exactly what encryption is based on. The bigger the numbers, the more secure the data. So yeah, good luck to those guys trying to crack our WhatsApp messages. There are some great videos on YouTube that explain this. Links are in the description. Really, there is no limit to what we can do with computer science. You could be creating platforms where you can meet new people, like Facebook. And if that wasn't enough, what about ways of reducing our carbon footprint? Not by re-engineering the engine, no, but by rerouting traffic, yes. And guess what? Remember the engineers and programmers I mentioned? I forgot to say, this industry is very tightly knitted. You could be designing hardware as a computer scientist or even writing programs. You just need to know the core elements. Oh, and knowing a language like Java or C++ is always a benefit. With that, you could pretty much go into anything. The world is your oyster. If you like this video, leave a comment, give us a thumbs up, subscribe, and if not, you know what to do. Oh, and if you really like this video, head over to Patreon where you can show your support.
All right, so I'm going to stop sharing real quick so that I can go back to sharing the just the PowerPoint rather than the screen here. 1 second as I find. Here we go. All right. So the nice British narration there for what is a computer scientist and what is computer science. So if you're here, it's because you're interested in one of our computer science programs, or at least thinking about joining us in computer science and weighing your options versus other pathways in School of Technology. So as it was gone over there, computer scientists are really both extremely technically proficient individuals, but also generalists within the field, right? There are a lot of specific areas like hardware design or within programming and software engineering where computer scientists can be found. And then there are very narrow technical focus areas and algorithms where you'll find the majority of computer scientists who are applying the latest cutting edge research in the field, right? So what sets a computer scientist apart from other fields, or how might you identify yourself as a computer scientist? There's a heavy math and problem solving inclination within the computer science field. We also have a lot of programming involved. So that's going to be an area that you'll always be touching on. And so if you're not somebody who likes programming, but you like math and problem solving, there are maybe some other areas of interest that you could go towards. A lot of computer scientists work on problems that are societal level problems, and so that's a common bonding point for people in the field. Also, self-starter, problem solver with trial and error, very analytical. If every one of these doesn't describe you, that's okay. There's a lot of these skills that can be learned as you go through the program, but these might be ways that you can help identify whether this is a field and a direction that you want to go. So I'll get to the master's questions and stuff. If you want to put that in the Q&A, we'll make sure that we hit those questions at the end. If you have a question that's related to something that we're talking about, I'll try and catch those in the chat, but if not, we'll hit them in the Q&A at the end. Computer scientists. So as the video went over, there's a lot of things that computer scientists can do. They're involved in really every field of information technology, of computing systems, and a lot of the more modern fields evolved out of computer science programs throughout the years. Career outlook. So there are, again, many fields that you can touch. Artificial intelligence is, of course, probably the biggest and most growing one at the moment. But related to that, there are applications of artificial intelligence and the algorithms that you would study around other techniques. Really, artificial intelligence techniques, machine learning techniques, these are just another tool in the toolkit for computer scientists who might be interested in bioinformatics or network or data science, right? Machine learning. So there's a wide range. And again, the idea that I stick with is that computer scientists are generalists, but highly technical and proficient generalists. So in our program, what will you learn? Algorithms is the basis of a lot of computer science. A lot of our programs and a lot of the topics that you'll learn are around algorithms. So, for example, our program has calculus and discrete maths. So you'll learn that in order to be able to apply cryptography, some data science, simulation, and modeling problems. We have artificial intelligence courses that would help you go into projects and fields for robotics and learn techniques that are being used for developing self-driving cars and smarter home assistants and so on and so forth. And then data structures and algorithms is probably one of the most core and fundamental areas for computer scientists. There are a lot of positions around data science that use heavily data structures and algorithms. Even just how we store and manage data is in large part a problem of data structures and algorithms, right? CS. So CS has come a long way, but we still have a lot of stereotypes in CS around it being, a lone programmer late at night, solving the world's problems individually. But the reality is that computer science and a lot of the IT industry is now a far more collaborative field than it's ever been. That there is career advancement deep within pathways for individual contributors, and that a lot of the work is being done across multiple languages, frameworks, platforms, and third-party systems, right? Job hopping is not a necessity. There is, of course, some benefit to job hopping in certain times. Right now, probably most people are sticking with their current positions until we see a cycle come back around where the jobs are more available, right? And then again, CS is a generalist type of topic of study, but it's definitely not very basic. It's very technical and deep in those areas that you are studying. For our bachelor's program, we include, and some of this was probably covered in the prior stuff, but we include all of our textbooks. You have course instructors available to meet one-on-one and to do group events. We have course communities now where students can ask questions and post things up for each other. And then we do have some third-party certifications in our undergraduate program. So the embedded ones are IDLE and LPI Linux. Those are third-party exams where you study and then go out and take that third-party exam for credit for your course with WGU. We also have some embedded micro-credentials like backend, AI, and Java. So those ones, after you complete a sequence of courses with us, those are applied to you, and you get to show off to prospective employers before you have the degree that, hey, I know backend pretty well. I can take these positions on. I know Java. I know AI, right? A lot of our texts are currently Zybooks, which is a very nice interactive textbook. We do a lot of programming directly in the textbook. It is, to my experience, a very modern experience for us, and very interactive and engaging to work with. So this is probably your primary resource will be Zybooks. We do have several other resources and vendors that we work with. But this is kind of the standard of the experience is these interactive textbooks, doing live coding within the textbook, and then taking that and applying it outside of the text, right? So what's different for the undergraduate CS versus, say, software engineering? They do have a lot of similarities and they do have a lot of course overlaps. However, software engineering focuses a lot more on development. It has web development. It has focus on things like mobile apps and very language-specific focus in either Java or C# tracks in software engineering. For CS, you'll experience C++, Java, and Python generally throughout your time with us. And you will take similar Java courses to what you would in software engineering. The big focus, of course, is on algorithms and the analysis and mathematics behind problem solving in the field, right? Difference between BSIT. So this is another common comparison because BSIT is known to be generalists, right? And they are. BSIT is a generalist where you're trying to gain a lot of skills that have value to a lot of positions in the IT world. However, again, the CS focus is on that high technical proficiency with math skills and programming skills to a level to be able to problem solve at a much more deep level for a lot of the types of positions you would be looking for. And it's generally not considered, whereas BSIT can then be a gateway to a future, program with more specific focus. BSCS generally is the program of focus and is what people want to study. We do have graduate level programs. I saw some questions about the grad programs in there. So we have within our MSCS program, we have 3 concentrations that all share common core courses. And this is a nice graphic for it. So in any of the programs, there are a set of courses that you can take. And while you're taking those courses, you theoretically could change your concentration pretty easily. However, a lot of folks do end up taking specific courses within the second or third term is most likely. So after an initial period there, you're going to lock into one of those concentrations. And the focuses are computing systems, machine learning, and AI, and then human-computer interaction. We have some descriptions for those to help folks. A lot of interest is in AI and ML right now, of course. And the focus in those courses is on emerging AI technologies, including natural language processing and deep learning and machine learning. These are all, of course, the most modern flavor of AI, but there are older techniques that have been in practice for a long time that are considered AI. And of course, there are new and emerging techniques that will continue to come out. Human-computer interaction is really looking at like ubiquitous designs, designs for software and for interaction with computing systems across multiple platforms, mobile, IoT type devices, things like this, right? And then it does include its own city IRB series that gives you that theoretical and practical application for it. And then we have the core computing systems with focuses in network architecture, cloud computing, IoT, object-oriented. So this is going to be more programming across a wide variety of devices and scaling them together, right? So differentiation. So why did we make a CS program here? Why did we make a master's CS program? We really believe in our model of competency-based education and students being able to accelerate and bring the knowledge that they have with them into the programs, right? And so we find a lot of value for our students with that, and we wanted to be able to implement that for the masters at the master's level. And then we also wanted to bring in some of the latest in AI and machine learning that we could to give students a chance for career advancement in a very rapidly evolving time and field. I mean, it's always been this way in the field, but it feels eternally like all of that is accelerating, right? We also have a bridge program. So for those of you who are interested in the undergraduate program, you might be considering getting the master's. And if you want to commit to getting those not simultaneously, but one after the other, and save some time by taking some of the graduate courses for undergraduate credit, that is our bridge program. It is able to save, I believe, a full term off of your total time to take both the undergraduate and graduate portions, and therefore lowers the overall cost to you as a student, right? So within that program, several graduate courses are substituted for undergraduate courses. However, all of the same third-party certifications are still available, and then all 3 tracks for the graduate programs are available. So there is nothing lost by being in the bridge program. Our graduate third-party certifications, I mentioned in the human computing interaction, we have the City IRB protocol review certificate, and then within the AI/ML track, we have the AWS machine learning specialist certificate. Admissions requirements, we do have specific admissions requirements for computer science. The first one for our bridge and undergraduate programs is generally you need to have some sort of pre-calculus experience or calculus level mathematics in your background. So you'll have to have a high school diploma and either successfully complete a pre-calculus course from WGU approved third-party provider, which I believe now WGU Academy also offers a pre-calculus course for that. Or if you have completed something that is calculus or higher within the correct time frame, those would also transfer in as an admission requirement. For our master's program, we do have standardly 2 ways into the program. Either you need to have had a computer science bachelor's degree granted by accredited institution, or if you have a degree in something other than computer science and you're interested in being like a field switcher or career switcher, you can take our Foundations of Computer Science course with WGU Academy as an entry requirement. These courses are relatively low cost, and if you enroll with us shortly afterwards, that cost goes towards your degree. So hopefully that is not insurmountable obstacle for folks who are interested. We just want to ensure that folks are coming in with the correct set of skills prerequisite to the program, right? All right, that is all my slides. So I know I saw some questions popping up here. I don't see anything in the Q&A, so hopefully we're able to track the questions over in the chat.
Yeah. So Matt, do you want me to kind of help?
I can see.
Do you want me to guide you on a couple of them?
We touch base on the business side with all 3 masters. So I would say that if you're interested more with the intersection of business operations and programming, that might be something more to explore with the masters in software engineering. There are more focused courses on requirements engineering and things like this over on that end. Certainly, business aspect is never fully ignored, but the computer science program does tend to lean more towards technical aspects, right? I'm trying to find questions here. Sorry, folks.
Yeah.
And I see people are starting to get over to the Q&A, so I'll look over there. And if your question hasn't been answered, please pop it over into the Q&A. AI DevOps for networking specifically. I'm not sure if I should get a master's in computing and get certs in AI or vice versa. Yeah, I think that this is kind of a difficult thing at the master's level. Right now, there are a lot of certifications out there for AI and ML. It will take time to see which ones prove to be most valuable in industry. So I think that the degree is valuable. Having a degree is valuable because it sets the base for expectations around your knowledge, right? But then you'll always be going out and finding those courses to update skills.
So is data engineering a good fit after taking BSCS? So this is why I really like CS, is because it is a generalist field to where you can take and shift into many fields, many adjacent fields. And so I would say, yes, data engineering is also a good fit for computer science majors. We also have a data program that has more specific focus in that area. So you have to consider if sort of the level of assurance that you have that data engineering is the field that you want to go into. Because if you weren't sure, I would say you go for CS. You have more opportunities just based on CS, but a lot of the skills overlap. So a strong portfolio of work coming out of a data program is going to look similar to a strong portfolio of work coming out of a computer science program. Course formats. So I'll briefly get into, there are objective assessment courses, performance assessment courses. Objective assessments are your more standard multiple choice type tests that you take in a live proctored environment. We also have live coding tests that are similar to that. We also have a lot of project-based tests, tasks where you are given a scenario and have to, develop, like for a software engineering course, you have to develop a plan for deploying software. For an AI course, you have to both do the technical portion of putting together some machine learning thing and then doing a little report on it afterwards, right? Admission requirements, and I'm sorry, I'm trying to, I should hit check, shouldn't I? This is, again, my first time in this new system, so I'm trying to learn it. Information about admission for this course. I had my transcript evaluated from MS Cybersecurity. Yeah, so I think for individual situations like that, working through your enrollment counselor is probably going to be best. I don't know the specifics of yours. From MS Cybersecurity, you will still need to do the Foundations of Computer Science to get into the Masters of Computer Science course, program rather. So that is still necessary. The math requirements and expectations are still different between cybersecurity and computer science. So that is why we do that, or part of why we do that. Accelerated program in computer science has the same prerequisites as the bachelor's degree in computer science. So the idea is that you will do the bachelor's degree. We switch out a few graduate level courses later on in the program, and those graduate courses count towards both your undergraduate and graduate degrees. These were often called swing level courses in a lot of other universities I was a part of. So that's the idea, is that these are dual purpose courses, and by taking those, you'll do fewer overall courses and terms than just doing the undergraduate and then the graduate portion, right? Okay, trying to get through these last two questions here. I know we're at time here, so I will finish these last two questions, and then any further questions, please, contact through your enrollment counselor. We are in contact constantly with enrollment to try and clarify and answer questions, so no worries there. Also, if you're heading out, you will get a follow-up email within a few days here with recordings of this session, I believe, and all the other sessions if you were curious of multiple programs. Masters in ITM. Yeah, so again, Masters in ITM, you'll take the Fox prerequisite through WGU Academy, and then you should be granted admission into our Masters in Computer Science, any of the three pathways that you're interested in.
Mm-hmm. And then there was one more question, Matt, around, is human-computer interaction a form of advanced UI UX?
I would say that, yeah, it's very related to UI UX topics with a heavy focus on that, but also with the computing components and programming. Yeah, Benjamin, groundwork for many related fields. That is kind of the point of CS as a broad generalist, but with very high technical proficiencies. And I'm trying to answer Caleb's question here. I don't have a testing area. Currently doing. Of course. Sorry, go ahead, Holly, if you have an answer.
I was gonna say, I can help you with that. Yeah, if there's a private room, like some libraries have quiet rooms that are all enclosed with doors and nothing in there but a table and a chair. I know my public library does. As long as you have your appropriate webcam, your appropriate PC, and all of it checks out, your surroundings, you should be able to still test in a space like that, Caleb. Yeah, without an issue.
Yeah, absolutely. Absolutely.
Yeah.
All right, folks. Well, thank you all for joining us. Again, you'll get a follow-up email with all the recordings, and if you have further questions, please reach out and ask your enrollment counselors, and we'll continue to work with them. And we'll have another open house here at some point. I think in 2 months, 3 months here. So, thank you all. Have a great day.